Hello everyone, welcome to my class. I'm Dr.P.Ganesh from India. In this class, we are going to discuss about the transmission media, especially in computer networks. We all know that the transmission medium is a very important thing for any type of data communication. Without any transmission medium, you cannot be able to exchange the information. You cannot be able to send your data or information from one device to another devices. So in this class, we are going to discuss about the different kinds of transmission medium. First, we are going to discuss about where we can able to fit that transmission medium. It means that we all know that in computer communication, there will be a voice reference model and TCP/IP protocol switch model. In this model, where we can able to fit our transmission medium, we all know that it is going to be there below that. The bottom layer is going to be a physical layer. Below that physical layer only, the transmission medium is going to be there. So this transmission medium, we generally call it as in layer 0. So that's also we can call. So this transmission medium, we are going to see what is a transmission medium and what are all the different types as major classifications of transmission medium. For example, the guided and unguided two mediums we are going to discuss. Under the guided medium, there are three different kinds we are going to discuss, and unguided media also we are going to discuss. There are three different types of mediums we are going to discuss in this class. Let us get into the class. Now we are going to see the transmission media. As I rightly mentioned that we are going to discuss about the guided and unguided transmission medium we are going to discuss here. So first we will see an introduction. In this introduction, the transmission medium is in layer 0 because this transmission medium which is going to be placed below that the physical layer. We all know that OSI 7-layer model and TCP/IP4 or 5-layer model. In this, the physical layer it is going to be a common for both the models. So this transmission medium which is going to be placed under the below that physical layer. So we call it as a layer 0. So what is the major functionality of that physical layer is? So this physical layer which is going to monitor the transmission media as well as which is going to control the transmission media, because many networks they may use different kinds of physical layer connections and interfaces. So according to that, the transmission media also going to be used. See, in this diagram you can see that there is one sender is there and another side there is a receiver. So if the sender wants to send any information, either he wants to send a data or any kind of information to that particular receiver, then he has to exchange that information via that transmission media only. So that transmission media may be either it may be a cable or the data may be aired. So the receiver side, that receiver, he must have a device which can able to detect, which can able to receive that particular transmission media signals, then automatically that receiver can able to receive that data. Now the classes of transmission media. So the transmission media majorly there is a guided media and the unguided media. So under the guided media, the twisted pair cables and coaxial cables and then optical fiber cables. So these three things we are going to discuss majorly. And then in unguided media, we will be going to discuss the radio waves, microwaves and then infrared signals. Now first see the guided media. So the guided media which is going to guide as well as conduct data or an information from one device to the another device. That device may be either it may be an edge device or it may be an intermediate devices. Sometimes it may be a networking devices also. So this guided media which is going to conduct the data or information from one device to any other devices. So there are three types of guided media are majorly we will be using it. That three medias are twisted pair cables, coaxial cables and the fiber optic cables. So A signal traveling along any of these media, maybe a twisted pair, coaxial, or the fiber optic cable, which is directed and contained by the physical limits of the medium, because each medium has its own limitations as well as has its own characteristics. So based on that only, the signal can able to travel from one device to the another devices. Now first let us see the twisted pair cable. So this twisted pair cable consists of two conductors normally, which is going to have a copper and the plastic. We all has witnessed in our home itself, you can see that all the cables, whatever all the wires which is going to pass in our all the electricity line as well as our basic home networking devices, you can witness that there are twisted pair cables are going to be used. If you see that the twisted pairs, it will consist of a pair of wires. So if you take any one single wire, if you cross section it, then inside you can able to see that there is some copper and outside which has to be insulated by the plastic. So this copper wires are used to carry the signals, because here in this guided medias, other than the optical fiber cables, so remaining all other guided medias which is going to exchange the data in terms of electrical signals. So these copper wires are used to carry the signals to the receiver, and the plastics which is going to be used only as a ground references. So during the transmissions, our data, our channel may be exposed into an interfaces. So that interfaces, we can call it as colloquially, we can call it as a noise. And there may be some crosstalks may affect our both wires as well as which can able to create an unwanted signals along with our original information. So during the transmission, there are different types of interfaces may occur that we generally call it as an unwanted voice over the original informations. So here we have even in that twisted pair cable, we have an shielded twisted pair cable and then unshielded twisted pair cables also there. If you see that below diagram, if you see that below picture, the first one is a general picture example for one twisted pair cables. So inside that plastic shield there may be a multiple twisted pair cables may ply, and whereas in the bottom side you can see that the bottom diagram, the first one is which you can see that which is an unshielded. First one is an shielded. So shielded means you can see that so there is an in between that twisted wires and there is a plastic outside. In between there is some shield is going to be there. That is what we call it as some metal shields also may be placed there. So that is a shielded twisted pair cable. And then next one is, if you witness that there are multiple twisted parts of cables are plying. Outside there will be a common plastic shield is going to be there. That is an unshielded twisted pair cable. So how these cables are going to be connected, with that you can see that the right hand side, the third diagram, you can see that it is a connector. Even you can see in your home also there will be a landline connection, or it may be a intercom connections. Even that devices are going to be connected via this cable. And even for your desktop also, if you are going to connect via the LAN connection, wired LAN connection, this type of RJ45 cables are going to be used. Now let us see, there are different categories of unshielded twisted pair cables are there. So that categories are, we generally name it as per the standard, the category 1 to category 7. Category 1 may be each category will have different characteristics. The major characteristics what we are going to consider here is what is the data rate, what is the speed it can able to support, and the second thing is that what is the distance it can able to cover. So based on that, we can use it for multiple networks. What type of networks, what type of category cable can be connected. If you see in this table, the category 1 is up to the data rate is 1 Mbps. This was a very old cable. So that is a twisted pair cable that can be used for, it is a pair of cables are going to be there, that is used for our earlier telephone connections. Same way, the category 2, which is going to be a 4 Mbps, that can be used for a token ring. And then category 3, and if you go category 7, category 6 kind of cables are going to be used for gigabit Ethernet cables, because that is going to connect it with 1 Gbps speed, which may support for 1 Gbps or 10 Gbps speed. So there only that kind of category 7 or 6 kind of cables which is going to be used. Now next we can see that coaxial cable. This coaxial cable, even in your home also you can witness that there will be a cable connection in that television cable connection. That cable is going to be used as a coaxial cable. So here if you notice that 4 total layers are going to be there. The first one is the coaxial cable, which carries the higher frequencies than that of the twisted pair cable. If you see that the earlier twisted pair cable, there is a lot of possibility for interferences because it may not have that much shield is there. Only twisted pair cable only which will have only one shield. Other than that it is not there. So this coaxial cable, the central cable wire is going to be there. Outer side you can see that there are first one layer which is going to be a plastic cladding is going to be there, and on top of that there will be some shielded is there. On top of that again one metal shield, and then finally there will be a plastic outer jacket is going to be there. So this coaxial cable can carry the higher frequency signals than that of twisted pair cables. So this coax cables having 2 wires, one is a coax, has a central core which is a standard wire which was enclosed in an insulating shell. So outer conductor of metal foil which is a shield against the noise. So here there is a noise interferences which is going to be drastically reduced when compared to the twisted pair cables. So the bottom 2 diagrams, that is one is in a connector and another one is an intersection of that coaxial cables. The third one which is going to show that the BNC, barrel nail connector, which was an inventor name. So there will be a lock kind of things is going to be there. Once you plug in and you can lock it that cable. So here the categories of coaxial cables are RG58, RG59 and RG11. So here the major characteristics we will be considering that what is an impedances, because how much resistivity will be there against to that signal. So RG59 is 75 ohms and RG58 is 50 ohms and RG11 is 50 ohms. RG59 can be used for cable TV and 58 is for thin Ethernet and RG11 is going to be used for a thick Ethernet connection in a coaxial cable. Next we will see that fiber optic cable. In this fiber optic cable, which was made up of, there are 2 materials, one is in a glass or the plastic. So where here the signals, the data are going to be converted into a signals, that signals are in the form of light, whereas the earlier twisted pair cables and coaxial cables, all that data are going to be transmitted via the electric signals. Here the signals are in the form of light. So definitely the light is going to follow the light principles. So let us slightly recap that light principles. When the light travels from one place to the another place, it means that if it is going to travel one single medium or the one single surfaces, it is going to travel in a straight line. Suppose that same light which is going to travel from one medium or one surface to the another surface, by default when we call it as one surface to another surface or one medium to another medium, which indicates that the density automatically which is going to vary. If that density is going to vary, then automatically that light wave's direction also which is going to change. So the light changes the direction when going from an more dense to a less dense medium. So that's the same principle which is going to be used in a fiber optic cable. Now let us see how the light ray is going to bend. First, there are 2 important things we need to consider on a physics concept. there will be an incident angle, there will be a critical angle. So based on that incident and the critical angle, the light either refracted or it may reflected. If you see here, there is a more dense medium is the center, and outer side there is a less dense medium. When the signal travels from more dense to a less dense medium, when the incident angle is less than that of the critical angle, the signal is going to be refracted, which is going to away from that medium. Next is, when the incident angle is equal to the critical angle, then the signal is going to be refracted on the parallel to that line. It means that which is going to be reflected and refracted, and which is going to be a horizontal line. So our principle is, if we want to send a light signals, and that too which has to travel in a single medium, in a more dense medium, then our principle is going to be, when the incident angle should be greater than that of critical angle, then automatically the signal is going to be internally reflected. So the light ray is going to be completely bended. So in this mechanism, in this principle only, the fiber optic medium which is going to work. So here in this optical fiber transmission, if you see that the first diagram, so there is an input signal. So the transmitter which is going to converting into an input signal into light waves, depends upon what the optical fiber we are going to medium is going to use, and then that light rays are going to be, incident angle is going to be greater than that of a critical angle, then automatically the light ray which is going to be internally reflected and which is going to reach the destination. So at the destination receiver side, which is going to receive the light signals, which has to be converted into a signal, and the original information has to be retrieved. So in this principle only, optical fiber transmission which is going to take place. Now we are going to see the different modes of optical fiber. One is in single mode fiber. Major classification is single mode and the multi-mode. Under the multi-mode, there are two ways. One is in step index, another one is in graded index. Now let us see what is in single mode, what is in multi-mode, and under the multi-mode, what is mean by step index and graded index. So fiber optic cable propagation modes. First we will see the step index multi-mode. In this first picture, if you see that the density of the core remains a constant from the center to the edges. So the whole density of the core medium which is going to be constant. So all the rays are going to be internally reflected, and which is going to reach at a multiple signals, and which is going to reach at the receiver at a different frequencies. The same way, graded index multimode, here the density of the core which is going to varies from the center to the edges, which is going to vary. So based on that, the signals are going to be, multiple signals are going to be transmitted. So in this multi-mode fibers, the multiple signals are going to be transmitted, whereas in single mode, there is only one signal which is going to travel across from the transmitter to the receiver side. Here the step index fibers are highly focused source of light only. Now we can see the different types of fiber optic cables. The type will be denoted as 50/125, 62.125. So here what it means is that 50 means the core micrometer and 125 is for cladding micrometer, and then where it has to be used, whether it is going to be a multi-mode, graded index, or the single index which is going to be used. There are 4 types of fiber optic cable. So the below connections, you can see that fiber connection, you can see that there will be a common core, and then cladding, and then coating will be there, and then strength member which is going to be shielded as a metal, and then finally outer jacket is going to be there. So these fiber, how it is going to be connected with the help of some cable connectors that we are going to see. There are different 3 types of connectors: SC connector, ST connectors, and MT/RG connectors. These are all the 3 different types of connectors which is going to be used in a fiber optic transmission. Now we will see that unguided media. So the name itself which is going to indicate that there is no guiding medium to take the signal from one place to the another place. So without using a physical conductor, which is going to transport the waves, that we generally refer to as a wireless communication. So here the signals are normally broadcast in nature through the free space. So all the signals are going to be aired, so which is going to be available to everyone, but whoever is having the capability to receive that particular signal, he can able to receive it. For example, our FM radio, they will be broadcasting in some frequencies, 98.3 or 100.5, something like that. So whoever is having an FM receiver, they can tune it to that particular frequency, they can able to receive it. In this way, the data are going to be aired. Whoever is having the capability to receive that particular signal, they can able to receive it. Now we can see that what is the electromagnetic spectrum, frequency of the spectrum. So which frequencies can be used for what type of data communication. From 3 kilohertz to 300 gigahertz is for radio wave and microwave. There is no clear distinction between that radio and microwave, but anyhow, what frequencies they will be using it, let us discuss in detail. And then infrared signals can be used for 300 gig frequency and 400 tera frequency, and then after that, which is going to be a light waves. Here the propagation modes are the 3 propagation modes. One is a ground propagation mode, sky propagation mode, and the line of sight propagation mode. Ground propagation mode simply which is going to spread into that all the ground level where the signals are going to be spread, whereas in a sky, whoever has having the capability to receive that particular signal, they can able to tune it and they can able to get it. And the sky propagation, there will be a multiple locations, there will be some antennas will be there which is going to propagate into that sky, whereas it is going to be an ionosphere. So through that the devices can able to access. And then line of sight propagation, which is going to be it is going to be a signal which is going to travel from, it is on the line, which has to be tuned into that line of sight so that it can able to receive. Now let us see what is the bands. These are all the different bands. You can see that for VLF, very low frequency, 3 to 30 kilohertz. For watt propagation, it is going to be a ground propagation, and the application is for long range radio navigation. And LF is for low frequency, 30 to 300 kilohertz and ground radio beacons and the navigation locations. And the middle frequency MF is for 300 kilohertz to 3 megahertz. It is for a sky propagation and AM radios. And the high frequency HF is for 3 to 30 megahertz, and that is also used for a sky propagation where the citizens' hands and ship and aircraft, they will be used. And then a very high frequency is for 30 to 300 megahertz. Sky and line of sight, both the propagations can be used, which can be applications are very high frequency VHF TV and FM radios, and ultra high frequency UHF which is for 300 megahertz to 3 gigahertz, which is used for line of sight. After that, if you can see that all it is going to be on a line of sight, it is for a super high frequency or extremely high frequency. All that can be used for cellular phones, paging, satellite communication, radar communication. Those communications only it is going to be used. Now we can see that radio waves. So there is, as I said, there is no clear distinct demarcation between the radio waves and the microwaves in the electromagnetic wave spectrum. So the frequencies which are all going to be used for 3 kilohertz to 1 gigahertz, which we generally call it as a radio waves. So the frequencies from 1 gigahertz to 300 gigahertz, or we can use it for microwaves. So generally they will be using it for omnidirectional antennas for that radio waves. And for microwaves, the frequencies in 1 gigahertz to 300 gigahertz is on microwaves, which are all in unidirectional in nature. So the antenna which is going to transmit some microwaves, they can be narrowly focused. So where the sending as well as the receiving antennas need to be aligned in a straight line way, so that the unidirectional property, which is going to be a more advantage, as well as which is not going to allow that, which is going to have a less interferences when compared to earlier. So a pair of antennas can be aligned without interfering with another pair of aligned antennas, so that there won't be any interferences, which can be purely aligned, and the data communication or the information communication will happen. For that, there are two types of antennas. You might have witnessed many places, even in cellular antennas, you can see that parabolic dish antennas are going to be there. Common central focus point is there, or whichever the rays it comes, which is going to focus into a single point. The same way the horn antenna is there, where the waveguides are coming into that bottom to up, where that signals are going to be reflected onto the line of sight. So these antennas are unidirectional antennas. Now last we can see that infrared, where the frequencies from 300 gigahertz to 400 terahertz. So the wavelengths are from 1 millimeter to 770 nanometer. So which can be used for a short range communication. So it may be a infrared waves. We know that which is going to have higher frequencies, it cannot penetrate the walls. So which is not going to penetrate the walls. So what will happen is, which is going to prevent the interferences from other side. So which is going to use for a short communication. So for our best example, you can take in our homes, we may be using our remote, television remote, or any other gadgets remotes. So other people's or other some distinct people antenna waves, which is not going to disturb you, which is going to be a line of sight as usual. As I said, the higher frequencies, all that communications which is going to use for a propagation method is going to be a line of sight. So the short range communications, the IR mechanism will be used. Now let me recap whatever we have covered in this class. So first we have discussed about what is a transmission medium, and in computer networks, in a data communication, where the transmission medium has been fit into that, it is going to be a below that of the physical layer, that we generally call it as a layer 0. And then what are all the different types of medium we have discussed? One is guided media, another one is unguided media. So the guided media, there are three types we have discussed: twisted pair cables, coaxial cables, and fiber optic cable. And the same way in that unguided media, we have seen the electromagnetic spectrum, and then radio waves, microwaves, and infrared waves. If you have any queries in this, if you have any doubts or queries, you please drop into my comment line. I'm happy to respond to your questions. If you don't subscribe to my channel, please subscribe to my channel for my future videos. Have a great day. Thank you.